For our final mini movie in the topic of thermochemistry, we're going to look at an alternative way to get delta H by consideration of the bond energies that you might remember from last semester. If we think again of a general reaction, reactants go to products. Well, what we have to do to our reactants is we have to break some bonds between the atoms so that we can re-put those atoms together by making new bonds in the products. Breaking bonds is, of course, an endothermic process. Really important you get a handle on that. Think about breaking a bond. You have to put energy in to do it. So if breaking bonds is endothermic, making bonds is exothermic. And by putting those together with bond energies, you can get an approximation of delta H. So let's consider that with this equation again. Quite a few examples will be done in class and on the quizzes, but a nice standard reaction, N2 plus 3H2 goes to 2NH3. Now, because we're talking about breaking bonds and making bonds, we need to draw out the pictures of everything involved in this. N2 has a nitrogen-nitrogen triple bond. HH has a nice single bond, and of course we're going to be breaking those. And then in ammonia, we've got the nitrogen-hydrogen bonds, all of which need to be made. Now, looking at our table of bond energies, and of course I'd have to give you these, the energy of a nitrogen-nitrogen triple bond, 945 kilojoules per mole. You expect that to be big because it's a triple bond. Hydrogen-hydrogen bond, 432. Nitrogen-hydrogen bond, 391. So we can get these values from our table of bond energies. So now let's think about what we're doing. We have to break a nitrogen-nitrogen triple bond because there's a nitrogen-nitrogen triple bond in the reactant but not in the product. And that's going to need 945 kilojoules. We've also got to break not one but 3 hydrogen-hydrogen bonds. So that's 3 moles of hydrogen-hydrogen bond when we look at the stoichiometry of the reaction. So the energy required to break 3 moles of hydrogen-hydrogen bonds is 3 times 432. So the total energy that we have to put in order to break all the bonds to start off this reaction by breaking the bonds in the reactants, 945 plus 3 times 432 is 2,241, and I strongly urge you to check that. Now, of course, making. Well, making bonds is exothermic if breaking is endothermic, and all we're making are 6 NH bonds, 6 moles of NH bonds, 3 in each ammonia, but there's 2 ammonias in the reaction. So 6 times 391, that total is 2,346. So energy-wise, we have to put in 2,241 kilojoules to break all the bonds needed, but we get back 2,346 kilojoules when we make those bonds. Okay, so the delta H, 2241, got to put the energy in, that's positive, minus 2346, the energy we get back out. An approximation for this reaction, and it's approximation because we're using average bond energies, is minus 105 kilojoules. Okay, lots of stuff we'll do practice in class. We will not leave this topic until most people are really happy with it, so don't stress about it if it stressed you out in class. It's actually, once it clicks, relatively straightforward, so don't panic. Just try and work questions and work through the videos. See you in class.